because I think most of you are ready for it, or at least some of you. So let's go here and let's talk about arithmetic in Python. So first we're going to do integer arithmetic. All right, so let me just shove this to the side and bring up my Google Colab here and see if I can fit them both more or less on the screen at the same time. All right. Now, by the way, when you get tired of this old stuff and you don't want to leave all sorts of weird things you defined there, you do File, New Notebook. Okay, now I got a clean environment. So I'm going to paste in that stuff. So I define A and B to be 10 and 20, then I add and subtract them. So this is simple mathematics. So that should work as expected. And let's see how far I can go down and still fit on the screen. All right, there we are. So 10 and 20, you add them, you subtract them, you get the obvious answers. So that's reasonable. Any programming language would do it that way. And the same, of course, for multiplication and division. There, multiply them, divide them. As you'd expect, you just use a star for multiply and a slash for divide. Now, by the way, yeah.
Is there the module thing, where it's percent
yes.
is dividing and you get the remainder?
Yes. In fact, let's try that while we're here. There's something else. Let me try. Yeah, so let's do B.
B percent A.
Yeah, B percent A, just what I'm thinking. Let me put it here. Yep. So let's do mod. Let me do a few things here. Let's start with the one you asked for. I'm going to copy and paste. Okay, so modulus is going to be B percent A. That's going to be 20 modulus 10.
Which should be 0.
Should be 0. And if you're familiar with modulus, modulus puts the numbers on a ring and just goes around the ring. So 0 to 9, 10 is 0. Another 11 to 19, and 20 is 0. If you're not familiar with modular arithmetic, it doesn't really matter. We need it for encryption, but we're not going to be doing that too much in this class.
I have a really important thing to say.
Yeah.
Mod, like if I had forgotten about it during my first year coding in Java, it is one of the most useful things I've ever used because it lets you find, the way it works, because of the way it works, it'll let you figure out if a number is a prime number very easily. It'll also help you figure out if a number is even or odd because there's no function otherwise to figure that out. You just do mod of that, you do the thing you're trying to figure out %2, and if you get 1, it's odd, and you can put that inside of an if statement. It was so much easier when I changed my code. I had a code that needed to know that. And instead of doing that, I forgot it existed and did 150 lines of code where every single thing that was a double I did, I had an identical integer that I divide out, and if it came out to 14.9, it'd get rounded down to 14.
Yeah.
And so it was able to figure it out that way. But I simplified it and it went all the way down to like 40 lines of code. It was insane.
Yeah. Well, you remind me of a couple things. One is when I was in your position learning this stuff, I would have things that took like 50 lines of code and I figured out how to boil it down to 2, and I thought that was great and I should do things that way. And then I got a job at a financial company. And we had to calculate a payout with like 10 steps, and I would write one big equation to do the 10 steps, and my boss said, no, you can't do that. I said, why not? He said, there's no way to verify it's true. What you have to do in finance is you have to think differently. You have to do one step and then fill in the column of numbers, and do one more step and fill in the column so somebody can print it out and put a ruler across it and use a calculator and verify that every step is correct. You have to create an audit trail. And so I was proud of being clever and smart and have the most efficient way to do things. And I had to learn that in finance, you need the opposite. You need the most understandable way to do things and the way that can be checked. So it's very interesting, and what I learned there is when I had some job that would take 100 repetitive lines, that was often the best answer. And we would use a spreadsheet to create 100 lines of code and then execute those 100 lines of code rather than figuring out how to make a loop, because it would just get the right answer fastest. Often the stupid procedure is in fact the best way to get the job done. But anyway, yeah.
I'll be brief. 2 things. One, whether you do it the long way or the short way, generally please leave documentation. It's very useful for people like me.
Yeah.
And 2, have you ever heard of Indian code?
Well, you mean Indians from India? They're coding all the time. There's something special about Indians to code a group.
In a lot of in some IT places over in India,
Yeah.
they actually pay you per line.
Oh.
So a lot of them will try to put out as many lines for a piece of code as possible.
That's a terrible idea. Yeah, okay, that's ridiculous, yeah, but I know a whole lot of coders are Indian now, a lot of people outsource their coding. Yeah, but anyway, good, this is very good. I've heard of girls that code, there's groups to promote women in coding. Anyway, but the modulus is a good thing to know, but another thing that's interesting is two kinds of division. If I make this 10 and 20, and I take 10 over 20 with division, then notice what happened. When I run this, A and B are integers, but when you divide them, you have a floating point value, 0.5. Now, that's what should happen. If you divide, it's going to be a float. But even if I do B over A here, and the answer is going to be 2, it's still going to turn it into a floating point number. Anytime you do division, and often this is not what you want. Often you would like integer division. And if you want that, you use 2 slashes. And that will divide and round it down to the nearest integer. So now B over A is 2, not 2.0. And that matters. Of course, another way to do it would be to do it this way and then turn it into an integer with int of, just like you do in almost every language. This will turn it into an integer, if I can get the garbage out of the way. All right. There. That will print 2. That's another way to turn it into an integer, but the 2 slashes is a useful trick to do integer division, rounding down if necessary. All right, and we use that in the projects. So then you got some higher math. For higher math, you have to import the math library. So you import the math library, and now you can do things like exponentiation. 2 stars is exponentiation, and logarithm is math.log, the number and the base. So these are going to be logs base 2, which is mostly what we're going to use. In physics, you use log base 10 and log base e in math, but in computer science, you typically do log base 2 to count how many bits there are in things. So here's 2 and 4. A to the b is 2 to the 4, that's 16. 2 times 2 times 2 times 2. The log of 2 base 2 is 1, and the log of 16 base 4 base 2 is 2. So there's logarithms and exponents. And then we have binary and hexadecimal. Here's the next thing. And if you're not familiar with them, you will be. All right. So A is 7 and B is 24. So in binary, you just take bin, and that will express it as a binary value. Now in Python, when you use non-base 10 numbers, it puts a prefix here, 0 followed by a letter. So 0b means what comes after is binary, and 0x means what comes after here is hexadecimal. So 7 is 111 in binary because it's a 1 plus a 2 plus a 4. And that adds up to 7. It's 7 in hexadecimal. 24 is 18. That means it's 1 times 16 plus 8. And if you're not familiar with this, there's a project coming up where we'll practice these. And probably starting next time, I'll demonstrate a bit of it each time so people get good at this. Yeah?
Just a quick question. The thing on the left-hand side where you're getting the book, where is that linked? Because I'm trying to find it and I
You
can't.
mean this thing here?
No, the thing on the left.
This stuff?
Left.
This here?
That, yeah.
Oh, okay, all right. That's the project instructions, and let me point it out. This is good. Okay, you go to the class page. It's this one, VP20.
Basically, it's.
Yeah. Click that, and you'll see this page of instructions. Very
Oh,
good.
there it is. Oh,
Yep.
it's really small.
Yeah. On phone.
Is the middle one on there, binary games? Or is it?
No, it's VP20 above that.
Okay.
Yeah. Yep. Hard to do this on a phone. Anyway, so all right, that's binary and hexadecimal.
I don't know the one.
And now if you want to convert binary, here's another thing that is interesting about Python. It understands binary and hexadecimal, and by the way, octal, natively. You do not actually need to convert things for it to use it. You can define a variable to be F0 in hex or 11011 in binary, and when you print them, it will just revert them back to base 10 automatically. So it'll tell you this is 240 and that's 27. It understands these number systems. And so here you can FFF. Now these are strings, not numbers. FF and 11101.
Yeah.
So if you want to convert string values like this into numbers, you use the int function. The int of C in base 16. That'll interpret this string as a base 16 number, and this will interpret the string D as a base 2 number. So that's how you convert binary to decimal. And I think this is all the demonstration part. And now I just want to point out what you have to do for flags, and it'll show you the general structure of these problems. So first you got just some arithmetic where you have to do some steps like multiply and then divide and get a value. So I have to write some code very much like the code in the demonstrations. Then you got one where you have to use division and display the result in hexadecimal. Then you got one where you have to convert it to a log, and then you got one where you have to figure out how to use octal, which I have not demonstrated, and you might have to Google and read up on octal. And this is the way they're always going to be. And notice the first couple are what I consider required, 5 points and 5 points, then it turns into extra credit. So only 10 points is expected, but if you do extra credit, you get more. And in all my classes, there are tons of extra credit, so you can just do a lot of hands-on projects and pretty much ignore everything else. There's just a certain point total you have to get, and you can accumulate it. So I mentioned last time, most of my students don't even take the final exam. They just do enough extra credit projects that they have enough points for an A before that. And so I plan to have more and more difficult things up there for the more advanced students. The idea is nobody should be bored. So if you already know Python, the first 2 or 3 of these will be so easy you won't even notice. There should be some tough ones at the bottom to keep you interested. That's my plan. And I'll judge what to do as I see the first few rounds of projects come in. I'll get a clue where people are at. But it sounds like I got quite a few people that do know programming, which is what I was hoping, and so they'll be able to do tougher problems. But I'll keep them in the extra credit. If you can only do the beginning stuff, that should be enough. The extra credit is not necessary. So I think that's enough for one day. Let me stop this.